In this slideshow, I will explain how to name and how to write a formula for ionic compounds. Let's move to the next slide. The name of the ionic compound is equal to cation's name and anion's name. It is important to notice there are no prefix used. To name ionic compound, you do not use prefix such as mono, di, and tri, and so on. Let's move to the next slide. So let's look at the example of how to name the ionic compound for a given formula. Let's move to the next slide. So first example, formula is AlI3. So first of all, you need to realize this is ionic compound. Again, how do you know this particular compound is made of ions? How do you know this? Well, first of all, aluminum is metal. Iodine is non-metal. Therefore, you know that these chemicals must be made of ions. It must be made of ions. And remember, metal becomes cations, and non-metal part is anions. Let's move to the next slide. So next question is, so what is the charge of each ions? Well, always remember the periodic tables, the position of the periodic tables. Aluminum belongs to group 3A. Because it's a group 3A metals, it will lose 3 electrons and becomes aluminum 3+. Iodine belongs to group 7A. It should gain 1 electron, becomes iodide minus. Let's move to the next slide. So remember, name of the ionic compound is simply cation's name and anion's name. Therefore, cation is aluminum, cation. Anion's name is iodide anion. Therefore, the name is aluminum iodide. Because this is not the molecules, you do not use prefix. For example, this is wrong. Aluminum triiodide. That is wrong. You do not use prefix such as tri. Let's move to the next slide. The formula is CrO3. Again, you should realize this compound should be made of ions. The reason is Cr is metal and O is non-metal. Let's move to the next slide. The problem is, what is the charge of each ion? Well, the oxygens, you know what the ion's charge is because of the periodic tables. Oxygen belongs to group 6A. Group 6A non-metals always gain 2 electrons, becomes 2- charge. Therefore, the charge of the oxygen should be O2-. However, chromium is a problem. Chromium is in a transition metals, and elements in a transition metals can form different type of cations with a different charges. So you cannot use periodic table to decide what is charge. Let's move to the next slide. So how do you decide? Well, you know each oxygen gain 2 electrons. In a chemical formula, which is CrO3, so in other words, you have 3 oxide ions. That means total 6 electrons are gained. How many chromium cations do you have in a formula? There is only 1. Therefore, chromium must lose 6 electrons. And that means the charge of this chromium cation is positive 6. Let's move to the next slide. And remember, when you name the cations from transition metals, you must indicate the charge in a parenthesis. So in this case, the charge of the chromium is 6 plus, therefore you would say chromium, parenthesis, 6, parenthesis, and oxide. Chromium 6 oxide, that's the name. Let's move to the next slide. This is this formula, NH4NO3, is an interesting example. NH4NO3, the formula, you should realize this is also made of ions. The problem is, when you look at the formula, there is no metals. So how do you know this is made of ions? Because there's no metals. I thought that no metals means only non-metals means molecules. And how am I supposed to know this is made of ions? And the reason is you need to memorize what are the polyatomic cations. For example, NH4 in a chemistry, when you see the formula, NH4 means always it's ammonium ions, NH4 plus ions. NO3, when you see these patterns, NO3 in a chemical formula, you need to realize it's a nitrate anions. So it is important to realize or know polyatomic cations formula, because it will always appear in a chemical formula and you need to be able to recognize them. So in this case, this ionic compound, NH4NO3, is made of ammonium ions and nitrate ions. Let's move to the next slide. Now I will explain how to write formula for the given name. Let's move to the next slide. Sodium oxide. So what is the chemical formula for sodium oxide? Remember, this is ionic compound because sodium is metal and oxide is non-metal. However, this is not the molecules. It is made of ions. So what kind of ions does it is it made? Sodium oxide, first name is always cations and second name is anions. Sodium, what kind of cations does sodium makes? Remember, sodium is in a group 1A. That means always sodium positive, sodium plus. Oxygen is always gaining 2 electrons, becomes O2 minus. So sodium oxide is made of sodium ions and oxide anions. Let's move to the next slide. So now question is, remember, you need to make the number of electron lost and number of electron gained the same. Sodium ions lost 1 electrons. Oxide ion gained the 2 electrons. Right now, the number doesn't match. So how can you solve these problems? Well, if you have 2 sodium ions and if you have 1 oxide ions, the number should match. 2 sodium ions means you lose 2 electrons and 1 oxide ion gains 2 electrons. Therefore, number of electrons gained and lost are the same. So therefore, the formula should be Na2O. Let's move to the next slide. Lead 4 sulfide. Well, in this case, the name has a number 4. That indicates must be the ions. Now, let's find out what kind of ions in this compound. Lead 4 indicates the charge of the ions. 4 means lead is 4 plus. So it's actually easy to find out what the charge is because it's written. Sulfide. Sulfide is, it's anions made from sulfur atom. It's 2 minus. Again, how do you know it's supposed to be 2 minus? Remember, sulfur belongs to group 6A. Group 6A means always gain 2 electrons. Let's move to the next slide. Now, lead 4 plus lost 4 electrons. Sulfide gained 2 electrons. Again, the number of electrons lost and gained does not agree. So only way you could solve this problem is if you have 1 lead ions, 4 plus ions, and if you have 2 sulfide ions, then the number of the electron gained and lost agrees. Therefore, the formula should be lead S2. Let's move to the next slide. Iron 3 sulfate. Again, the 3, Roman numeral 3 indicates that's the cations with a charge of 3 plus. So therefore, you have the ions 3 plus ions, cations, and you have sulfate. Well, sulfate it's a name of polyatomic ions. It is SO4 2 minus. Let's move to the next slide. The ion 3 plus lost 3 electrons. Sulfate gained 2 electrons. Again, number of electrons lost and number of electrons gained are not the same. You need to make them same. So you need 2 iron 3 plus cations, and you need 3 sulfate 2 minus anions. Then number of the electron gained and lost is equal to 6. So you write Fe2 parentheses SO4 parentheses and 3. When you indicate, for example, you have 3 sulfate ions, you must use parentheses so that you could tell there are 3 sulfate ions in the formula. Let's move to the next slide. Remember, in this chapter, the main objective is for you to understand how things are made. Some things are made of atoms. Sodium metal is made of atoms. It's a sodium atoms. Some things are made of molecules. Chlorine gas is made of chlorine molecules, Cl2. And some things are made of ions, cations, and anions. Let's move to the next slide. And in this table, I compare the difference between ionic compound and molecular compounds. Remember how to name the compounds are different. Ionic compound is simply you use name of ions. Molecular compound, you use prefixes such as carbon dioxide. Remember, in ionic compound, the bond between cations and anions are simply electrostatic attractions between positive and negative, which is called ionic bonds. In a molecule, the bond is called the covalent bond, and it is sharing of valence electrons. And the table summarizes other differences in chemical and physical properties. This is the end of the slide 3.